In engineering, we often talk about tools, how they're improving, how they help us model faster and design better and work smarter. But what happens when the tools you need don't exist yet? And no one's building them for you. On the show today, we're joined by Sebastian Masset. Sebastian is a civil engineer who works in stormwater and wastewater design, but when his local authorities shifted their modelling standards and the existing tools couldn't keep up, he didn't wait for a new solution. He built one. Using Python and a lot of trial and error, Sebastian developed an automation engine that cut a 2-hour stormwater modelling task down to just 5 minutes. No developer background, no software team, just a domain expert who decided to figure it out. If you've been following the show, you'll remember that we spoke with Brooke Smith, a cloud-native calculation platform for ClearCalcs, and Jordan Butler, modelling snapback in complex structures. But today's episode is about something else. What happens when engineers stop waiting for software and start building it themselves? Welcome to the Structural Intelligence Podcast, the show where we explore the intersection of engineering, technology, and innovation. I'm your host, Owen Keenan, structural engineer, entrepreneur, and tech enthusiast. Each episode brings together innovators, experts, and thought leaders who are pushing the boundaries of what's possible in engineering and technology. Through deep conversations and practical insights, we explore how new tools, techniques, and mindsets are reshaping our industry. We hope you enjoy this episode. Welcome to the Structural Intelligence Podcast. I'm your host, Owen Keenan. I am a founder, tech enthusiast, and also structural engineer. And we're exploring how the tools and mindsets of engineering are evolving. In today's conversation, we dive into a different corner of civil engineering, which is stormwater. But our real focus is on a civil engineer who, without a formal coding background, decided to take on some complex modeling challenges and ended up teaching himself how to build his own working automation tool. So my guest is Sebastian Masset, a civil engineer who works in stormwater and wastewater design and recently deployed an automation tool for HEC-HMS, a stormwater modeling platform. His journey from spreadsheet to workflows to scripting Python bridges the kind of gap which we love to explore on the podcast. So Sebastian, welcome.
Thank you very much. Good to be here.
Yeah, it's good. So that's my little spiel, but I'd love for you to introduce yourself and give us a little bit of background on, I guess, your background. Yeah.
So I'm, as you mentioned, a civil engineer by trade.
Yep.
How I found my way there is actually a bit of a long way. I always like creating and building things as a young person. So I went into building houses back in New Zealand, and then started studying civil engineering. Once I completed my engineering degree, because of my construction background, I found myself more in the construction space, working across New Zealand, mainly like utilities, roading, stormwater. And working on some large construction projects here in Western Australia. And then I found myself in the design office managing a small team of designers, and that was actually quite a good place to be, sort of managing the project from concept to construction, being able to straddle both those worlds. Where I found myself particularly is sort of in the water space, mostly municipal stormwater, flooding, and small on-site septic designs.
Yeah, great. Yeah. So my background also, I have a bit of a civil engineer background too. I used to work on land developments and that sort of thing, and building the roads and the drainage and all that. But I think it's really cool to hear a bit of a traditional engineering, like civil engineering background. Do you have any specific projects that you sort of remember in the past that you're sort of working on that are of highlight to yourself?
Well, you caught me there.
Yeah.
In particular projects, I think some of the large construction projects that I've seen in Western Australia have been pretty impressive, particularly around the resources industry. I think just for the sheer scale of things, which is much more, much larger than what I've been exposed to in New Zealand, particularly. However, I think possibly where I call home, a small place on the east coast of the North Island of New Zealand, it's a small place, but then you have to be sort of quite strategic, or being able to be very clever with your designs to sort of solve a particular problem. So I know that there are a couple of those that I'm particularly proud of.
Yeah, that's great. And so talking to that a little bit, I know we've talked a little bit about the stormwater design and other things like that. Can you give us a bit of a background on those specific things? Because that sort of leads into a little bit about the discussion about some of the things that you've been building.
Yep. So I'll speak mostly for the area that I'm familiar with, which is the small town where I come from. But then this is a problem that is global and that a lot of local authorities are struggling with. The short of it is that when humans develop, we create a lot of impermeable surfaces. So we're talking like your roading, your roofs. So if you imagine a paddock and then it becomes like a subdivision with roads and roofs, you've effectively changed that landscape. And from like a water management perspective, from a stormwater management perspective, that could be a problem because you're shedding more water more quickly than, say, when it was a paddock previously. And that can cause problems such as flooding or localized flooding or other downstream effects. So this is a consistent problem that local authorities are trying to grapple with, not just in New Zealand, but definitely in Australia and globally for sure.
Mm. And so that's so what sort of things would you do there to sort of solve those problems as that comes along?
Yeah, so it is quite a big scope, and it does sort of straddle a traditional built environment or an engineered solution versus maybe natural solutions, or the natural environment. And what engineers try to do in that situation is to limit the effect that you're going to get on the downstream environment, such as your rivers or your streams, or even just municipal flooding, being able to control that. Really, it's about controlling the water in some way, so you can like slow down the water. That could be such as like using green roofs to kind of just like absorb the water and release it slowly. People might see large ponds around, and that's another way to hold and capture water and just sort of control it. And there's a variety of methods, or you can sort of direct discharge to ocean. So without going into a lot of detail, it's really about controlling the water to slow it down or to manage it in a more manageable way.
Yeah, that's right. Yeah. And so obviously you probably have a few tools and stuff that you use to calculate that, also to manage that. I'm sure that the councils and other things have their own requirements around the runoff and how that works and things like that. So just to give us a bit of a picture, what does that look like right now? And how does that workflow for you work as a civil engineer doing those things?
So I'll preface that by saying that with climate change happening is that does affect things as well in terms of the severity of these storms that engineers or councils need to manage. So that's just sort of an overarching consideration. However, to answer your question, there are many tools out there, but this is going to be a perfect segue to what we'll talk about later on, is that the old method, should you say, or like a method is called the rational method. It's a formula that you can use, and you can use it as a spreadsheet, and it's been used, I'd argue, successfully in many places for a long time, and it is still sort of the standard for a lot of other places around the world. So all that is just sort of getting a percentage and figuring out a percentage of your runoff that will be coming off, say, a paddock versus a tin roof. So that was the method that was mostly employed, and there are other methods, which is what we'll talk about later on.
Yeah, that's great. So one thing to sort of think about, and I wanted to really discuss, is as engineers, we've all got our own workflows, where whether it's a stormwater drainage calculation, or for me, I'm a structural engineer, so whether it's a building or beam calculation, and then we've got the different tools that we set up to do that. One thing that struck me about sort of when we met was the fact that you were delving into the world of software engineering in a way, in a domain expertise, but maybe not coming from a software engineer background, And so at what point did you start thinking about using software to potentially automate some of your workflows, or to make the process of which you were doing maybe some manual tasks, and using the solution of software in your space?
So I probably need to go back a little bit, and I think I've always talk a little bit more about my software journey.
Sure.
I think that's important. I think, look, I've always been interested in software, and I remember the first time I got exposed to it was when I taught myself HTML back in sixth form. I put together a website to share school ball photos amongst friends. And unfortunately, it sort of stopped there. That was probably the peak of my software engineering career,
Yeah, right.
sort of right then. And then since then, I've always been interested in it. I remember one Christmas trying to sort of teach myself JavaScript through a book manually, which didn't amount to much. And then since then, probably I'd say like dabbling with some success, creating small scale automation scripts just for things that I was working on. So I think I've always been interested in more dabbling, I suppose. However, I think this year when I woke up January 1st, I was just like, look, this year I need to learn how to code because I've always been interested in it. And I do think that it is a valuable skill, especially when you combine it with a non-software engineering field.
Yeah, definitely.
So there was the motivation there. And I did have like another idea or another project or goal that I was going to work on. However, how it segued into what I actually worked on was that the authority that I work for back in New Zealand, they changed the conditions of how these stormwater assessments were to be assessed. So what we were once able to do using the rational method, as I explained previously, and now I needed to use a particular software tool. It was a free software that you can download. It took a little bit of time to figure out how to use it. But what really struck me, and I think this is probably like common for a lot of people, if you actually think about what you do on a day-to-day thing, and it doesn't actually have to be a workflow. It could just be like your regular life. How much we sort of run on autopilot and just do things because that's the next step.
Yeah.
So I think we get sucked into that. And when I was using the software, I actually realized that it was quite laborious in a way. I mean, you had to set up your folder structure. You had to download rainfall models. You have to alter those rainfall models. You have to build like a model within HEC, and then you have to do a bunch of other things. And then once you've done that and debugged it, you have to iterate numerous times.
Right. Yeah.
So I think sort of, I wouldn't say that it was like frustration, but I think I'm always trying to connect the dots to sort of see if there's sort of like a simpler way to do things. Okay. And after a couple of times, I just asked if the computer could do this for me.
Yeah, that's right. That's an interesting place where we find ourselves. Like, for example, as civil engineers or as domain expertise engineers, we will always look for, like, how can we do this better?
Yep.
In a way. And I love that that sort of narrative around, we always have those situations. And sometimes we go, status quo, let's just keep going, or it's too hard.
Mm-hmm.
There's someone above me that doesn't even want to bother with it, so I'm just going to do it the same way. But then there are some that go, actually, I can do something a little bit different here.
Mm-hmm.
And from what I understand is you sort of thought about it and you thought, okay, I could actually do something with coding here. Would that be right?
Yeah, that would be right. That is correct. The reason for my hesitation was just that the time that it's taken me to get to this place,
exactly.
Sort of quite, I don't know how the cost benefit would work out for that, but I think it was just more just to see if I could.
Yeah. What's possible?
Sure.
Yeah.
And look,
that's great. Yeah.
And I think that's a really probably important mindset to have, especially with how the world is changing.
Yeah.
In that area. Yeah.
Definitely. And I think just posing that sort of mindset, which is, I could probably give it to the developer to do and it'd probably take a week to do it and then that'll be fine. But the skills that we need moving forward, particularly with the advent of AI, generative AI, machine learning and other things such as that, what starts to happen is, everyone has access to these tools that have intelligence, that are able to do certain things, so sort of segueing into that a little bit. And I loved how you explained it was actually a bit of a journey, some things I'm assuming you had sore points, you had debugging points, you had all these sorts of things, but I'd love to just drill down into that a little bit and to talk a little bit about what the tool that you've built, just get into some specifics and sort of map your journey doing that. Because I think for our listeners, more particularly, is that sometimes we all, like I said, stand at that sort of moment where we're like, we could do this better. Do we invest the time to do it?
Mm-hmm.
And I think your journey and listening to what you do and maybe the pitfalls and the other things might be instructive thing. So the question I had is, okay, so dive into the tool. What is it called? Okay, what does it do? Maybe we can start with just the general basis of it. You mentioned a little bit about how you needed to follow a different software, different workflow for your calculations. But do you want to give us a brief overview
of the tool that I built?
Yeah.
If I may, I might just talk about just jump on something that you said before, and
sure.
Being able to like package something up and give it to the developer, and they could do it in a couple of weeks. I think initially I was overly ambitious with how long I thought this was going to take. I thought it was going to take me a couple of weeks, and it's taken me more than a couple of months.
Yeah.
But that's an interesting point that you raised with sort of packaging things up to a developer. And look, probably the next time, I think that's a different skill in and of itself, actually being able to sort of set something for someone else to follow. But then also, speaking personally, I think you'd be lulling yourself into like a false sense of security because you're still wanting like an output from them. So you still need to drive that process. So like, I think that's probably a different set of skills than what I've learned from doing this. But also I think I do also see that as like a valuable place for the whole overall software development picture. But I think if you've spent some time in the digital trenches, when you're starting to use those other things available to you, like working with others to build software for you, you're going to have more of an idea of what can happen, what can go wrong, so you can actually talk a little bit of the same language. So look, this is a little bit outside of what we're initially talking about today, but I think that was an important point.
Look, I'm glad you raised that because it's probably getting into the more philosophical understanding of, as domain experts come closer to being able to create things quicker and have the tools at their disposal to like prototype, which we didn't necessarily before. We had to be that architect which orchestrates between the software engineer and other things. Like you said, that's a different skill. That's the interesting part because the domain expert understands deeply the solution for their domain as well. So I think we'll get into that a fair bit too. If you can take us through the tool. Yeah.
So the tool that I built from like more of a technical perspective.
Yeah. I'd love to do a bit of a drill down and take us through your journey with the tool.
So HEC is a suite of programs. The one that I'm working with, I think, is called HECFlow, and there's HEC-RAS, which I haven't played with. It's a free software that's built and released by the US Army Corps of Engineers, and I'd say that it's quite powerful and how it runs models or rainfall models and runoff, probably more of like from a statistical point of view. So that's the back end of it. It seems a little bit janky. It's got like this funny user interface that you sort of use, but it seems to work maybe sometimes somewhat temperamentally. So again, as I said, I figured out I wanted a way to automate that, just to try and sort of improve my workflow. I think sort of on any given time, maybe like the workflow I described before might take me around 2 hours just to sort of build the model and get the data, get the results that I needed. So once I figured out that I wanted to automate it, I needed to figure out how to actually do that. And HEC is written in Java, which I don't know, and I only know like a little bit of Python, so I was more comfortable with that. So I had to try and like build a tool in Python and get it to control HEC in a way that I needed to control it. What was quite difficult, I think, is because there was no API for me to actually talk with the program.
Yeah.
HEC. And look, I did lean probably a little bit on ChatGPT to try and sort of figure out a bit of the internal structure of this HEC program, but it was also a bit of time of actually just working my way through the folder structures of HEC and trying to figure out how it was actually built.
Yeah.
I was pretty proud of myself when I figured out, I guess, the Achilles heel of the program was that I realized that there were a bunch of building block files in the back end of HEC, which could just be edited in a text editor. So all my program had to do simply is just change those and switch them out, and then the program would run. So that pretty much made me the puppeteer of the program there.
Yeah.
So look, that sounds trivial talking to you about that now, but like, trust me, it took a long time to find that out.
That's the thing. So you talk about, okay, we've got an existing, program. Do you call it HECFlow?
Sorry. Yes, no. So the tool that I'm like trying to develop, I've named it HECFlow.
Okay, so that's the one you've developed, and the other one is just HEC, is it?
So it's called HEC-HMS. So that's the actual software that does the heavy lifting.
Yeah.
So HECFlow I built as an automation tool to run my particular workflow through HEC with minimal control from me.
And so that HEC-HMS was that Java-based
Correct.
Java-based program that's by the Army Corps of Engineers.
Correct.
US Army Corps of Engineers, but it didn't have like an API you could plug into it or anything like that. So these are the building blocks that you start to think about. You're like, oh, okay, this is how this program that I have to use is working.
Mm-hmm.
You know, you've sort of dived into the back end, maybe a little bit of documentation / filing structure, document structure, and you begin to see how these things are set up. And what I found was interesting is like, okay, you started to understand the architecture, but you probably had a bit of an assistant there, which was the ChatGPT, or like using AI as a basis to start to understand how these things might go together for you. Would that be right? Or
probably like a little bit of both. I think I probably need to say that cautiously, because my journey, and we'll talk about this soon, I'm sure, is that it actually threw up a lot of red herrings. But I think in terms of trying to get condensed information quite quickly, even if it wasn't necessarily correct, did help advance your thinking instead of reading a whole lot of not white papers, but software documentation.
Right.
I think probably a big part that I do need that's probably worthy of mentioning is that there's a lot of experimentation here, and I think that's probably what actually helps. So, for example, once I had like an idea, it might turn out to be like a dead end.
Yeah.
But then also, when I sort of thought, for example, the folder structure or the file structure, I'm just like, oh, let's run an experiment. So you just switch things out, then you open it in the user interface, and it actually works. So then all of a sudden, like, there were little breadcrumbs along the way but that is just sort of time at the keyboard and pretty much experimenting things, not necessarily trying to break things, but trying to sort of tease things apart. And once you might have that breadcrumb, you can probably feed that into chat, and it might give you a more targeted direction or a thing to consider. So there was a little bit of like weaving through the maze for sure.
So you definitely use it as a bit of a co-pilot tool in terms of, you know, where it would enhance what you're trying to do with your coding and understanding of the system as a whole.
So yeah, and I'd say that I definitely used it as a co-pilot for multiple parts of the process. So I'd probably say what I just described in terms of trying to navigate my way through things that wasn't necessarily coding. It was more trying to figure out the structure of HEC.
Yeah.
And then obviously definitely using it for the heavy lifting of the actual coding when I got to that. But, you know, I guess you can just get responses from it so quickly. So it's quite easy to just sort of throw whatever you're pondering into it.
So okay. So you've got, just to pull it together, so you've got the existing workflow or program that you're looking at, HEC-HMS, and then what your automation and workflow does. What's the end result? Like, how has it helped you in terms of, now that you've built it, what's the outcome there? And then maybe we can talk to some of the pain points that you had trying to get them working, and like what was it that actually helped you to get to the point where you had your resolution at the end?
Sure.
Because I'm sure there's a bit of a journey there.
Yes, absolutely. So the gist of it is that if people want to develop, they need to control that water, and quite an easy way to do that is to control it through attenuation tanks. So the water will run off a roof, gets captured in the tank, you throttle that flow just to slow it down to pre-development levels. The catch is you need to figure out where that peak is and manage it. So that's what that's what that program does. So as I described before, to build these models and to run these iterations, quite a laborious process. I think possibly on any given day, I got pretty good at it, but you know, probably about 2 hours by the time you're downloading all the subsequent information that you need in the rainfall data to crunch that. So the HECFlow that I developed, pretty much you enter an address, which is the property address, and it downloads all the information. So it scrapes the internet to get the rainfall data that I need. It manipulates the rainfall data and builds the HEC models. So now I've just got like a project file, and then it keeps going. So then it actually performs the iterations, and at the end, the user will get a list of tank and throttle arrangements that comply.
Great.
Yeah.
So you've gone from, all right, we get a job in, working it out maybe in a spreadsheet or chucking everything in, going onto the internet, grabbing all of the data, pulling it back in, making the file structure, and then taking that, doing a first run, iterate, second run, iterate, obviously do as many as you need, and then you get your report, which is at the end, and it tells you, oh, these are the suggested for your specific runoff.
Correct.
And so you've taken that from sort of a manual, more laborious system to, I can plug in here, plug in there with your HECFlow tool to streamline that.
Correct.
Pardon the pun.
Nice, I missed that.
Yeah. So, okay, so that's great. I think that's a really interesting piece because as other people relate to your situation, it's like, oh man, they probably have a few different projects, few different tools that they think they can automate in that way, you know. Probably something that I really wanted to get into is that link between AI and doing this whole process. So there's probably a scenario where, okay, if you didn't have it, could you achieve the results that you would have achieved now? Would it take more time? Like what would the difference be in having a ChatGPT assistant as opposed to not?
Yeah, that's a really interesting question, and that's a good question too. So that's, I think, so look, I only use ChatGPT, so you can probably collectively say AI coding tools because I think there's a number out there. So when I say chat, we can change that term there. Look, I think they're a double-edged sword because on the one hand, they're amazing, but at the other hand, they're frustratingly difficult. And I don't want to say stupid, but they are like a neutral tool, I think. However, one time in ultimate frustration, I actually said something bad to ChatGPT, and then I actually felt a little bit guilty because if it decided to pull the plug, I'd be, I don't know, I wouldn't be able to finish what I needed to do. Yeah. I think it's, if I was thinking about that, if I was to try and go from my level of coding that I had before doing this project and trying to build it by myself completely, I don't know if I'd say that I'd never get there, but we're probably talking years.
Yeah. Well, there you go.
We're probably talking years to get to that level to sort of be able to do that. Like it's been very helpful in terms of, for example, when I had to bridge between Python to the Java program, it was very helpful to figure out exactly what was needed and figure out, for example, path names and actually narrow down on that. And I don't know how I got that information, but even for me to find that on the internet probably would have been very difficult. So I would say going, and I guess we can talk about sort of managing the architecture of the build using chat. I'll talk about that soon. But I guess its ability to code, it is exact. So it won't be missing commas or it won't be missing colons because that coding is very exact. And if you don't have those, it breaks. So in terms of being able to write the code for you, that was good. However, I think probably the biggest limitation that I found with using ChatGPT to code this was that the architecture, its understanding of the architecture wasn't there. So that was probably my dominant role in making sure that we got to the end from the structure and building the program, how it actually needed to work.
That's it. It's an interesting, and it's quite a significant statement, which you think years, obviously understanding the programs, understanding the language. You probably have to come from a basis of understanding these languages first and then getting into the build.
Yeah, sure.
So how long did it actually take to build this?
So yeah, initially I mentioned, I thought it was going to take me about 2 weeks. I thought it was going to be quite a simple sort of undertaking. I wasn't working on it full time, but probably a couple of hours a day, sometimes more, or a couple of hours every other day. I think I started in March. So what are we now? So about 5 months.
Yeah.
Look, I mean, it's a strange one for me to say. I think it's I think probably you're your own worst critic. Well, I certainly am. So I think I need to probably not hold myself to the fact that it didn't take me 2 weeks and the fact that I actually got to it at the end. And effectively learning something new, going from effectively zero to actually building something. And maybe actually sort of grasping the lessons learned along the way. And actually the next time I do this, obviously the time would shrink down, I would imagine. So
and that is significant because, from years to months, right? But months part-time, overall, maybe if you sat on it for a couple of weeks, it would have been done. And, but the thing is, like, this is the situation where we find ourselves as engineers, as domain experts. We're not sitting there coding every day, are we?
No.
We are doing technical work, delivering, whether it's consulting or construction or whatever it is, we're delivering that to a certain extent. And sometimes as an afterthought, automation and coding, such as this, will be a bit of a back burner thing. And for the effort that we need to put in, right? That's what it is. But what you've demonstrated here is to go, okay, actually, I'm going to allocate a portion of my time to making my workflow better so that I can do it better. But not only that, you've gone, I actually want to learn this stuff. It's pretty interesting, And I think curiosity for engineers at this stage right now is so important, because otherwise intelligence work, the things that we do, the things that we know, is going to be trumped by the skills that we develop and how to use these systems. And so where you've come, you've done that iterative bite, that small little iterative bite. I reckon I can automate this workflow, which you've done. You've used ChatGPT or an automated AI tool to help write the code and things like that. It's helped you architect it, but you're delving into that space where is starting to blur with between the software engineering and the actual nuts and bolts engineering, which is pretty interesting. And I think that it's a great lesson for any engineer listening to go, oh, actually, if I want to get into this space, I just need to start. That's what you did.
Yeah, look, it's a good thing that you raised there. I think probably the tool that I've built to automate my workflow is pretty niche. I think there could be some further applicability for the HEC suite of programs to automate those. But look, I think this was probably more driven by, I wonder if I can. I think how our world is developing, especially with AI, is that our systems aren't going to become less dependent on it. They're going to become more. And I think a traditional engineer with a capital E, I don't know. I don't know if that's necessarily a thing of the past, but I think as technology is advancing, you need to be playing in the sand, so to speak. So I think sort of the bigger play for me was to see if I could, and to actually develop those skills to sort of be the bridge between two worlds.
Yeah.
And I think getting software skills for non-domain experts, I think that applies disproportionate leverage to their skill set, which is what the world probably needs, not only for themselves, but the world as a whole. And I think probably a good metaphor is that, from a civil engineering point of view, is that if you need to dig a big hole, you could do that with a spade or an excavator.
Yep.
And I think non-domain experts getting some software knowledge is just turning up with the excavator.
Yeah, definitely. So I know we talked a little bit to the tool and things like that. I really am excited to hear what you've been building, and I hope people take it as a great example for you can build what you need. And that sort of leads us into sort of another theme that I really wanted to talk about, was that democratization of building our own engineering tools. You sit here as somebody that's done that, and I've had a bit of experience in that. I do a lot of structural inspections. I've built a AI tool, like an AI assistant, which comes out with me on inspections and takes my notes. It's a voice inspect, so it takes my notes as a voice agent. I talk to it. It tells me if I'm missing anything, and it challenges my assumptions with regards to like causations of failure and things like that. And it assists me in writing my reports. And like you, like I find, oh man, it's gone from an hour and a half to 2 hours on site to an hour on site and maybe another hour in the office as opposed to doing a half a day report. And so, like, I think a lot of engineers are having experiences with this now. And what I'd like to sort of talk about is that that concept of the domain expert being able to prototype and build their own tools. And so I guess for you using it, how do you see AI-assisted coding or tools like ChatGPT changing how engineers engage with software?
Well, firstly, I think speaking to your journey, I was pretty blown away when you showed me your inspection tool. That was very cool.
Yeah.
Very cool. So how can engineers utilize AI to build software?
So how is it changing?
How is it changing?
How is it changing how we engage with software in a way?
Well, I think it depends because I think you actually have to engage with it first because I think not everyone does.
Sure.
So we'll assume that people that are interested or are actually engaging with it. Look, it's pretty incredible, I think, that the access to the power that we have now, and I'd probably guess that it's only just going to get better. And as I said, I only have experience in using one AI tool, and I imagine there's others out there that are probably even better. As you mentioned before, the democratization of software, I think we're probably going to start to see some really cool things come through with non-domain experts actually being able to start to incorporate some of these ideas or actually build leverage into their existing workflows or their ideas by using software, which would otherwise take them years to learn to prototype something, as I explained before, that they months or weeks that they could actually sort of throw something out there, whether or not that was like a product for other people to use or actually streamline their workflows.
Yeah.
So look, I think this is some powerful stuff that's coming. So I think probably the key thing is that people do actually need to engage. And you mentioned the word curiosity before, is that I think that's very important. It is a different way of thinking. It's abstract, but then also explicit as well. And probably a thing that I realized is that a stumbling block that I found is that, for example, when I did my manual workflow, is that when you're looking at the results, it's quite easy to think, oh, that's a bit too much or that's not quite enough, and sort of make those mental adjustments quite easily. Oh no, we just need to sort of look at this, or that's not quite right. But the problem with the software is it doesn't understand the nuance. So like every thought of just like, oh, is that too much or is that not enough? That needs to be an explicit instruction in the software to handle that. So I found that quite a challenge in terms of transcribing my workflow into a set of code instructions.
Yeah, so we've got we've essentially got whether it be a workflow or a discipline that you're sort of working through, and just enhancing that with enhancing that with the AI or automation. One thing that I really want to highlight, which you said, is you just got to get in. You just got to get curious. You just got to jump in and see what you can use it for. Because yes, it is. Like I think there's some apprehensions with people using it, and they say there's different aspects and different criteria. But some people might use it and say, "Oh, it's just not giving me the right answer," which might be correct. That's true. Like it's probably not giving you the right answer. But are you using it and leveraging it for the things that it can do really, really well right now? And I think as time goes on, if you haven't taken those baby steps to just mess around with it and jump into it, whether it be on a chat platform like a ChatGPT or using APIs to enhance your automated workflows that you've got already, or using AI agents that have a goal and an understanding of what you need to accomplish, and it does that. I think if you don't take your baby steps, you're never going to get there, you know?
Yeah, absolutely. I think you do just need to get exposure to this. And as I said before, you know, our world isn't going to become less dependent on these tools.
No, exactly. So what advice would you have and would you give to engineers that want to build their own tools, right, but don't have a software engineering background?
I think, as you just mentioned before, I think the key thing would be to get started. I can only speak to Python because that's what I've been exposed to, and that's what I used. And there are actually a bunch of automation tools out there that are off the shelf that you can probably start automating workflows as well without needing to go a bit more into the software engineering route. There will be like a learning curve. However, I think ChatGPT will be very helpful for that. For example, setting up your Python development environment, you'd probably be able to do that in less than an afternoon with the assistance of chat. Probably a big thing that I would recommend engineers do is start small. The thing that I found really challenging with this project was that it actually turned out to be really big.
Yeah.
And I think it was naivety that got me started. And then pretty much I was so close to the end by the time I realized how big it was that I just had to keep going. Otherwise, I would actually have nothing. So probably my advice to people getting started would be to start small and try and really niche down on a particular workflow or work point to automate, especially if they're new to it, to get that working and to probably set up a situation so that you can get quick wins, because that's the ultimate motivation. Whereas if you're weeks into something that doesn't work, it's pretty demoralizing.
Yeah, no, that's it. So true. And I guess long term, do you see yourself building more tools? And I guess, do you see yourself helping others to do the same?
So, yes, I think I might take a small break to let, I guess, this whole process just sort of distill a little bit and just to sort of think about the learnings and let my thinking evolve. But then, yes, I think I'll be getting back into something else quite quickly. Look, I find it fascinating when it works. And I have like a bunch of other projects that I like to get started or experiment with, especially in the engineering and automation space, sort of that bridge between those two worlds.
Yep.
I don't know if I could support people to get into it other than, I suppose, speaking about it if people ask me questions, but I don't know if there's anything in particular that I could do to sort of support people getting into it.
That's true. I suppose when you sort of find your bit of a niche, there'll be always people come out of the woodwork and say, how do you do that? As always.
Yeah, no, definitely happy to chat. I think the interesting thing is that it's if it's something that you live and do, or if it's your worldview, which it has been over the past number of months, I guess I don't know any different. So I suppose when someone actually says, oh, wow, that's pretty neat, or how'd you do that? I guess that's sort of quite a refreshing bit of feedback.
Yeah, definitely. So at the end of each show, we hand it over to the AI host.
Uh-huh.
They'll wrap up, give us a bit of a summary and ask the question. So I will hand over to the AI host now.
Sure.
Sometimes the most impactful changes in engineering come from those who are willing to bridge the gap between disciplines. Sebastian, as we look toward a future where engineers are also tool makers, how do you see this evolution influencing the way we tackle challenges in the industry?
I reckon it's going to give a lot more power to the whole industry, and for people to really prototype. I think we're going to see some amazing things come through.
Great. Absolutely. It's exciting to imagine the kinds of innovations that will emerge when engineers feel empowered to create their own solutions. It's truly a bright future ahead. If you enjoyed this conversation, definitely stay tuned for more.
That's great. Thank you, AI host. So just to, I guess, finish up and to round it out, because a few things that I've certainly learned in having this conversation is that, it doesn't matter where you're at in the stage of your engineering, whether you're a grad or whether you're experienced, we all have the opportunity to delve into these tools and to begin to understand how we can use them, And I really like that point of being able to see the domain experts. So those that have the technical understanding of their own domain, being able to prototype and build what they want to build. So that was definitely an insight from me. I guess, do you have any final thoughts as well?
No, nothing in particular. Otherwise, I'd sort of be repeating myself, I think.
That's great. Well, I really appreciate you having me on the podcast.
Yeah, thank you.
And so if this episode sparked your curiosity about how engineers build their own tools, follow me on LinkedIn or drop me a message. We'll link to Sebastian's tool if and when it comes available. And if you're enjoying this podcast, the Structural Intelligence Podcast, please subscribe or share to a fellow engineer. So the frontier of engineering is expanding. Let's be a part of it together. If Sebastian's story resonated with you, maybe it's time to try building something yourself. So the tools are out there and the frontier's open. Thanks again.